When you learn a tool, it may not seem that interesting at the time, but the chances are that later it will be useful for something that you are interested in. So it's worth learning the tool properly the first time you learn it. Hi, I'm Professor Philip Clark. I'm a professor of experimental particle physics at the University of Edinburgh. I'm teaching a course on fundamental physics, which is looking at matter at different scales, so seeing how the symmetry of physics repeats itself from the very small scales of quarks to very large scales such as black holes and cosmology and the universe itself. There's a variety of levels sometimes of the students in the class, but because the classes are relatively small in terms of the number of students per professor, I can spend a lot of time tailoring how we actually do the mathematics to the student and helping them and really make sure that they understand how to do the different mathematical processes. And also using a physical example can help give a flavour to the mathematics so that the student actually not only can do the recipe of how to derive a mathematical equation, but actually have a feeling of what it actually means and what it can mean in a physical situation. And the second aspect is in Mathematica, it's using symbolic mathematics, and that and Python programming are very useful to also to help elucidate the mathematics. So you can make plots of the various outputs and again make simulations within Mathematica and Python. Even the very best students, after a certain period of time, a student will lose attention just because it's difficult to stay focused for a long period of time. So I often I interrupt the class and I get them to answer a question. So I display, like for example, multiple choice questions on the board, and I let them discuss and then try to answer the question. Another aspect is that I mix up using writing on the blackboard, and this also helps them learn to take notes and so on, and slides and then examples. So it gives a bit of variety to the class, and this helps keep the students focused during the lectures. Every piece of mathematics or physics that we learn it comes up again in different areas of physics. And one of the themes of the course is that we see the same kind of patterns and symmetries being repeated in other areas of physics. So one tip would be when you learn a tool, it may not seem that interesting at the time, maybe because of the way it's presented or the use it's being used for. But the chances are that later it will be useful for something that you are interested in. So it's worth learning the tool properly the first time you learn it. Physics is actually a very remarkable discipline because it's adaptable to many different career choices. So you can go into electronics, optics, fluids, you can go into fundamental particle physics, you can go into space physics, you can also just, if you want to specialize in computing and informatics, you can do that. And many people also go into finance and economics and modeling. So it's a degree that it's very highly thought of and it's very adaptable to whichever. So say when you start your degree, if you're not sure what you want to do afterwards, physics is a good thing to do because at the end of it you have a lot of choices in what you can choose as your. Whereas if you pick say just economics or engineering, you become quite specialized in that particular area. So physics is quite versatile.